analysis. Welcome to the Chapter 2, Lesson 3 notes video. All right, so we are going to graph linear inequalities today. I know this is pretty basic. I actually just did this with my algebras a couple days ago. So get a blue pen and get you started. A lot of this stuff is real nice and simple. Inequality symbols are pretty much all of your comparative symbols that are not an equal sign, right? So less than, greater than, less than or equal to, greater than or equal to. Also, and I of course didn't mention these back in Algebra 1, but not equal to is an inequality sign technically, and approximately is an inequality sign technically, because they are indicating these are values that are not necessarily equal. In this case, definitely not. In this case, pretty close, but not quite. All right, so we, of course, will continue using these first four. That'll be our deal as we're going. I mean, if you have read through my notes, you are reading them in my voice because it is totally, I have written your notes out. So it is me who is talking. And I know if you, especially as you're getting to know me, because now we're a full chapter in together. But those of you who knew me from freshman year, you can hear me talking as I'm going through this. So it's not just that you need this video necessarily. Also, anything that I've written out here is what I'm talking about. So a lot of times I insert these pictures to just to give a visual element to the fact that I've written out a textbook for you. And really, you could do this without all these videos. You know, you could do this course without a lot of these videos. So speaking of referring to the number in question, right? So every time I'm talking about a solution set with an inequality, I'm talking about how does your variable compare to some number? And so I always call that the number in question. And so in this case, the number in question is 3. Okay, I just picked a random whole number, and that's what I'm using. So on this particular number line for this particular solution set, 3 is my number in question, and my entire arrow is an open circle over 3, and my arrow is covering the parts of my number line where nothing, it's all smaller than 3. The part that doesn't have anything covering it is the part where x is greater than 3. None of this is covered by a line and arrow. And so here, these are all the values that will make my inequality true. This is the solution set. Anything that is smaller than 3. Why aren't we equal to 3? Well, because this is not a closed dot. This is an open circle. So it's just calling that, this is where I'm starting to think about the stuff that will make this true, but it's everything that's smaller than 3 is what will make this true. Okay, everything. And remember that this number line, there are an infinite number of numbers between each of my whole numbers that's represented scale-wise on my number line. So there's a lot of stuff here that is working. Okay, that is being true. Okay, so when I'm graphing linear inequalities in a 2-variable plane, an xy plane, right? So I took 2 number lines, put them together at their zeros, and I call this a coordinate plane, all right? When I'm doing this graphing, it's not just, it's the comparison of the x and y that is what needs to be covered as a shaded area on my graph. Everything in the shaded region counts as a solution set. So all those things that count in this 2-dimensional plane, all of them are points that make this true. To take care of the open circle or closed dot issue, that's the solid line versus dotted line. So graphing in y equals mx plus b form is still the case, even though I don't have equal signs. All right. I'm still going to find a y-intercept. I'm still going to use a slope to count from point to point. But that is the line in question. And you might not be able to call those points the solution if you don't have an equal to part on your inequality sign. Okay, that's not what you'll be able to do. And so I just want to kind of verify, right? The solid line is when you've got an equal to part underneath. The dotted line is when you do not have an equal to part underneath. So as I go through the M and the B, I'm also going to go through whether solid or dotted and whether I shade above or below the line. And I will explain further the above or below and how I figure that out. This is pretty straightforward. Again, needing a straight edge because we're graphing straight lines. Okay. All right. Example 1 is y is less than x. Okay. So what's my slope here? Well, it's a 1. There's a 1 over 1 in front of my x. What's my y-intercept? Well, nothing's being added or subtracted off the end, so it's 0. And that means my first point is 0, 0, right? Now, my inequality sign is a less than. So this is going to be a dotted line, and less than means shade lower. And so I'm just sketching it out over here so I have an idea when I get into it what I'm going to do, but I'm going to show you how I use the y-intercept to determine higher or lower. So 0, 0, up 1, right 1. So I'm getting some points on here. Opposite of up 1, right 1, down 1, left 1. And now again, I've already determined I'm going to use a straight edge to draw this, but I've already determined this is a dotted line. So I put my straight edge up against this, and as I draw this, I lift my pen periodically. You should be using pencil. I use pen because you need to be able to see it. You won't be able to see pencil as easily. Also, signature color is totally aqua, not turquoise, aqua. Get it straight. Now, promised a y-intercept, higher or lower. Put your pencil on the y-intercept. My y-intercept value is 0. I know I need to be less than. So since my y's need to be less than, I count less than 0, which is -1 and -2 and -3 and -4. See what side of the line I'm on? This is the less than side. This is the lower side. So what I do is I shade in this region. Be careful to contain that region. Write your inequality in it. So this is y is less than x that goes in here. Everything in there is a y is less than x solution set. Every single point in there. Okay, all of that. All right, let's do it again. Y is greater than or equal to -x. Okay, my slope is -1 over 1. My y-intercept is 0, so I'm going to start at 0, 0. This is a negatively sloped line, so I'm going to go this direction, but this time it's solid because I've got an equal to part, and it's greater than, so I know I'm going to be shading above my line, the greater than. And again, it's sometimes hard to figure out lower than the line or higher than the line, depending on your slope, so I'll show you again using that y-intercept. So 0, 0 is my y-intercept, down 1, right 1. So notice opposite direction, right, because it's the opposite slope. What's the opposite of that? Up 1 and left 1. So only one negative move occurred here. Take your straight edge, hold it up against this. This time, it's a solid line. So solid line, arrows at the end. Remember, I'm still covering the whole graph, so all that stuff from the last lesson, totally true. Covering the whole graph. Now, go to your y-intercept. Put your pencil on the y-intercept. And now we have greater than or equal to is our symbol. So from 0, what are the y values that are bigger than 0? Well, they're 1, they're 2, they're 3, they're 4. See, my pen has gone up the y-axis and has gotten me on the side of the line I want to be on. This is the side that's greater. This is the side that gets shaded. All these points inside this shaded region are the solution set. And this time, all the points on the line are part of the solution set. This is the closed dot situation. This is the equal to. The equal is part of this, greater than or equal to. All of it in here, and this is where we label. Always label an inequality inside the shaded region. Okay, always label an inequality inside the shaded region. Continuing, of course, with this, you also have horizontal and vertical issues. So here's a horizontal. I know because the only variable present is y, so that's the only axis I'm going to touch. My y-intercept, of course, is -2, so 0, -2 is my start. And because it's horizontal, my slope is 0. So 0, -2, and my slope is 0, so that's straight across. Grab my straight edge. Oh, I didn't write it over here, so this is going to be straight across, right? This is a dashed or dotted line. I always say dotted. I always say dotted line. I don't know why, but dashed or dotted mean the same thing. And notice it's because we don't have an equal to part. Now it's greater than, right? So we're going to be greater than this. Well, it's really easy to figure out with a horizontal what's up and what's down from it. So you draw your straight across dashed line, of course, up against your straight edge. Arrows at the end, cover that whole graph. And now everything above that is part of the solution set. So everything above that gets covered with your shading. And then this is where you label your inequality. Y is greater than -2. Done. Vertical. A little bit different story. Of course, the slope is undefined, right? We don't have one. We're only touching the x-axis because that's the only variable present. So that's how I know this is straight up and down and vertical. There is no y-intercept, but my x-intercept is -2, which means I start at -2, 0. So let's go there. Okay. And from here, is my line solid or dotted? Well, we've got a less than or equal to, so it's going to be solid. And it's less than, x has to be smaller than -2. So where are the smaller than -2s? They're -3, -4, -5. They're to the left, right? Because if we're talking about it that way, less than left. So this is going to be the less than part. And right is going to be greater when it comes to vertical lines. So take that straight edge, draw that line straight up and down, and shade. And now here, everything to the left plus the line itself satisfies this inequality. It's all part of the solution set. And x is greater than, less than or equal to, well, I can fix that pretty easily. There we go, less than or equal to -2. All right. Not too bad. The only additions are thinking about solid or dotted and thinking about solid or dotted and thinking about where to shade. And again, use that y-intercept for the functioning ones and use the x-intercept as the comparison for this. So left is going to be less, right is going to be greater when it comes to a vertical line. A couple more examples, and then you're on your own. Here we go. Y is greater than 2. How about you can see it? Y is greater than 2x minus 3. Okay, so my slope is 2/1, positive. And -3 is my y-intercept. And this time, it's greater than. So this is going to be positive slope line, dotted or dashed, and greater than means above it is going to be shaded. So that's what we want to think about when we go to do our shading. So here we go. Y-intercept, 0, -3, 1, 2, 3 down here. Cool. Up 2, right 1, up 2, right 1. And if I can't go up to right 1, I go back to my y-intercept and go down to left 1, because that is the opposite, still a positive slope direction. Use that straight edge. Remember, we said dotted, right? No equal to part, so dotted or dashed. Now, go to your y-intercept. Greater than was our symbol, so count up from the y-intercept. That would be -2, -1, 0. These are all greater than -3, right? And so this side of the line is what I shade. That's where the solution set is. Every point in here satisfies this inequality. The line does not satisfy this inequality. That's just the border between what works and what doesn't. And then here, y is greater than 2x minus 3. There you are. Next, y is less than 1/2 x plus 3. Cool. 1/2, it's positive slope. 3 is my y-intercept, so 0, 3 is where I start. No equal to part, so this is a dashed line. Again, positive slope, so there we go. And less than will be lower than it. Let's see if we can figure that out. 0, 3. And up 1, right 2. Up 1, right 2. If I can't fit any more up 1, right 2s, I can go back to my y-intercept and go down 1, left 2. And I do that for a little bit, then grab my straight edge. Not a solid line, I just determined that. So dotted or dashed, whichever you prefer to call it. Arrows at the end, covering that whole graph again. It's very important to cover that whole coordinate plane that we've been given. No domain limits have been given to us on any of these so far, so don't worry about it. Okay, less than 3. Go back to the y-intercept. Count smaller than 3. Count lower than 3. So less than 3 is 2 and 1 and 0 and 1 and 2. Aha! This is the side of the line with the solution set. And y is less than 1/2 x plus 3 gets labeled inside. How we doing, guys? We're doing great. Awesome. So glad to hear it. Slope of -2/1, y-intercept of -3, 0, -3, and a less than or equal to, this is a negative sloped line, so got an equal to part, it's solid. And less than, going to be shading below. See if we can figure that out. 1, 2, -3 down here. Down 2 and right 1, because it's a negative sloped line. And if I want to go opposite, it's up 2 and left 1. And there we go. Okay. Solid line, already determined by the less than or equal to sign. Cover the whole graph, arrows at the end. Less than -3 is, let me scooch this up just a little. Less than -3 is -4, -5, -6, -7. Look what side of the line I'm on. That's less than. That's the side that gets covered by the shade. All right, y is less than or equal to -2x minus 3. So everything on the line and everything in the shaded region makes this inequality true. Last, and then it's on you. -1/2 slope, +3 y-intercept. So 0, 3 is my y-intercept value. This is a negative sloped line. It is solid because there is an equal to part of my inequality sign. And we are greater than, so we're going to shade above the line. Start with 1, 2, 3 right here. Down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. If I don't want to do down 1, right 2, go back to the y-intercept, up 1, left 2, up 1, left 2, up 1, left 2, and take your straight edge, create the solid line connecting, arrows at the end, cover that whole graph, put your pencil back on the y-intercept. It's a greater than symbol, so greater than 3 is 4, 5, 6, 7. Look what side of the line I'm on. That's where we shade. Everything in the shaded region and on the line satisfies this inequality. Y greater than or equal to -1/2 x plus 3. Okay, so even with different slopes and going different directions, you can very easily figure out where your shaded region should be based on your using your y-intercept as kind of an example. Okay? All right, kiddos. I think you got this. So go do. And I shall see your answer soon. Let me know if you need anything. Have a great night. Bye, guys.